In programming, data structures are essential tools that help us organize and store data efficiently. They allow us to manage large amounts of information quickly and easily. Today, we'll focus on two foundational data structures: arrays and linked lists. Understanding these will help you write better code and solve problems faster. An array is a collection of elements stored in a fixed, contiguous block of memory. Think of it like a row of lockers, each with its own number. You can easily access any locker by using its number or index. In Python, here's how you might create and use an array. Numbers equals 10, 20, 30, 40. Print numbers 0, hashtag output, 10. Arrays are great for quick access because you can jump directly to any item using its index. However, they have a limitation. The size is fixed once you create the array. If you want to add more elements, you'll need to create a new array. Common operations like insertion and deletion in arrays can be slow, especially if you need to shift elements around. For example, inserting an element at the start of an array. Numbers.insert 0, 5, hashtag insert 5 at the beginning. This operation requires shifting all other elements down, which takes time. A linked list solves some of these problems by using dynamic memory allocation. Unlike arrays, linked lists don't store elements in a contiguous block. Instead, each element, called a node, contains a value and a reference or a link to the next node in the sequence. Visualize a linked list like a chain of connected train cars. Each car holds a passenger, the data, and a connection to the next car, the link. Here's how a linked list might look in Python. Class node. Def __init self data. Self.data equals data. Self.next equals none. Class linked list. Def _init self. Self.head equals none. Inserting and deleting elements in a linked list is more efficient than in arrays because we don't need to shift elements. For example, inserting a node at the start of a linked list is very quick. New_node equals node 5. New_node.next equals linked_list.head. Linked_list.head equals new_node. However, linked lists take more memory because each node stores an additional pointer. Accessing elements is also slower than arrays because you must traverse the list from the beginning to find the element you want. So, when should you use arrays versus linked lists? Arrays are great for fast access when you know the index, but they require a fixed size and can be slow to resize. Linked lists offer flexibility because they can grow or shrink as needed. They excel at fast insertions and deletions, but are slower for accessing elements. Each data structure has its strengths, and understanding when to use each one is a key part of becoming an effective programmer. In summary, arrays and linked lists are foundational data structures that every programmer should understand. Arrays offer fast access, but come with size limitations, while linked lists are more flexible, but slower to access. Keep practicing, and soon you'll be able to pick the right data structure for any coding problem. Happy coding!